Welcome everyone to Math 100, Section 1.1, Understanding Whole Numbers. So the objectives today, we're working on expanded notation, converting back and forth between word names and numbers, and interpreting numbers in tables. So first thing today is expanded notation. An expanded notation is a way to break up a number into its parts. So let's take a look at 2,483. Now each of these numbers has a specific meaning. 3 is in the ones place, so each one there is just worth 1. So that one is just worth 3. But here, we've got a number in the tens place, so each one there is worth 10. So you multiply 10 by 80, and this digit in this number is worth 80. The 4 is in the hundreds place, so each number there is worth 100. We have 4 of them, so that's 4 times 100, and that digit is worth 400. 2 is in the thousands place, so each one there is worth 1,000. So that means the 2 here is worth 2,000. So we can rewrite this number using the values of each digit. And we'll just add them together. So we add these things together, and together they're going to equal 2483. So this is expanded notation for a number. All right, example 1, we're going to write the number 5,271,032 in expanded notation. So for each number, all we have to do is take that number, so I'm going to take the 5 here, and then all the other numbers just become zeros. So I'm going to fill in 6 zeros, and we get 5 million. So that digit's worth 5 million. And I'll do the same thing for 2. And then after that, we'll have 5 zeros, 1 for each digit that follows the 2. So that one's worth 200,000. Do the same thing for the 7. And we'll follow that by 4 zeros. Then the 1, 1,000. We got a 0 here, so you don't even have to include that one. Skip over to the 3, and that's worth 30 if we fill in zeros. And finally, a 2 on the end. Now if you take these, stick them in a calculator, and add all those up, we're going to get 5,271,032. So same number, just another way of writing it. All right, now we're up to your turn number 1. Now it's absolutely essential that you do the your turns on your own. It's a really important part of the learning process. So what you should do now is stop the video, work on your turn number 1, then when you're done, unpause it, and then compare your answer with mine. Now I'm not going to stop during making the video, I'm just going to continue right on to your turn number 1. So make sure you pause it and work on it on your own. Alright, your turn number 1, we've got 27 million. 81,000. 374. Alright, we'll break this thing up, start with a 2. I've got 2 followed by 1, 2, 3, 4, 5, 6, 7 zeros. Or 20 million. Now the 7, that turns into 7 million. Now we'll skip over the 0, go right to the 8. And here we'll have 80,000. 8 followed by 1, 2, 3, 4 zeros. 1,000. 300. 70. And 4. Now we can convert in the other direction. You can go from expanded notation to standard notation. All right, so here's example 2. And we're going to write the number 300,000 plus 7,000 plus 200 plus 5. We're going to convert this back to standard notation, or just a regular number. Okay, so we got a 3 in the 100,000s place here. And now, do we have anything for the 10,000s place? Nope, we have nothing that is followed by 4 zeros. So that's just going to be 0. All right, now we have 7,000, so 7 goes in the thousands place. We have 200, so we got a 2 here. And no 10s, so another 0 here, and then a 5 on the end. So this number in standard notation is 307,205. All right, your turn, number 2. Go ahead and pause the video and work on your turn, number 2. Now we'll convert this to standard form. We have some missing values. There's nothing in the 100,000s, and there's also nothing in the ones place. Looks like we have the rest of them. So we're going to start with a 9 in the millions place. No 100,000s, so we'll skip over that and put a 0 there. Now for the 10,000s, we got a 3. For the thousands, we have a 6. For the hundreds, we got a 4. For the tens, we have a 2. And nothing for the 0, so 9,036,420. Now on your handout, next thing you see, there's the place value system. You need to become familiar, if you're not already, with the names of all the different place values. Because the next thing we're going to do is be converting between place names and numbers. So you can break all this up into groups of 3. Just like we have numbers here, separated into groups of 3, separated by commas. We're going to do the same thing with the place names. We got them broken up into the trillions section, the billions, millions, thousands, and ones. So example 3, we're going to look at for the number that tells us the number of 10 millions. So we're looking at the number 837,291,564. So which digit tells us the number of 10 millions? All right, so we got the ones, thousands. Here's the millions over here. And the middle digit is going to give us the 10 millions, all right? These tells us 1 million's here, 10 millions, 100 millions. So that's the number we're looking for. So the number 3 tells us the number of 10 millions. All right, your turn, number 3. Which digit tells us the number of 100,000s? All right, so we have ones here, thousands here, 110, 100. So the third digit gives us the number of 100,000s. So we have 800,000s. Example 4, we're going to find the value of a specific digit. So we saw here in example 3, that the number contains 3 10 millions. If we want to find the value of that digit, we take the 3 and we multiply it by the value at that place. So it would be 3 times 10 million. Or 30 million. So the value of this digit in this number is 30 million. And we saw that when we went to expanded notation, when we were adding all those together, this one would be 30 million. And that brings us to your turn, number 4. What's the value of the digit 8? So in this number, we're going to take that 8 and multiply it by the value at this digit. This is the 100,000s position. So we'll take 8 times 100,000. And that gives us 800,000. So the value of the 8 in this number is 800,000. All right, now we're up to a really important section, writing the word name for a number. We'll see why this is important later on. So if we want to convert a number to a word name, we're going to break that number up into its comma-separated parts, convert that number, and then attach the value on it at the end. We'll see how that works. So this is example 5. And the number is right now each one of these is going to have a specific meaning. So we'll take this 23 here. Write it out as a word name. And now let's look where on this chart that it lies. So here's your first group. You got 1, 2, 3, 4, 5th group over. So if you look at the chart, you got ones, thousands, millions, billions, trillions. Trillions is the 5th group over. So this means 23 trillion. And then put a comma after it. So we got 23 trillion. Now we'll move on to the next group. Now we'll write this number, this 3-digit number, as a word name. It's 815. So we got 815, and which group is this? It's the 4th one over, 1, 2, 3, 4, that's billions. 815, and then just write billion after it. All right, next group of 3, 263, 263. And that is the third group over, so ones, thousands, millions, 263 million. Notice I'm not putting the word and in here anywhere. Some people do that. That is incorrect. There are no ands. And has a specific meaning in math. We're not going to include it in the word and. All right, next group over, 910. And that is the second group over. That is the thousands place, so 910,000. Finally, last group, we have 735. And since that one's the ones place, we don't need to put anything after it, and there's the answer. Your turn, number 5. So go ahead and go to the usdebtclock.org, find the current national debt. And you can see the national debt is increasing so fast that you can't even really see the numbers on the end, so you can just make up some numbers for that one. That's what I did. All right, I'm just going to roll with the number that I got when I visited, and that is 26 trillion. Kind of hard to believe. And that's the number I got. By now, the number that you get will be larger. All right, let's do this one. So we got 26 trillion. Go to the next group, 634. And that is billions. 995 million. $461,000. $297. All right, now with the calculator, take whatever number you got and divide it by 330 million. And that'll tell you how much the U.S. debt is for every citizen. Well, now when I did that, I got $80,712. So to convert that, $80,712. So what you really need to be good at is just converting these 3-digit numbers into words and then attach whatever extra word you need on there. Trillion, billion, million. And that's all it takes to convert these. So make sure you can convert any 3-digit number. All right, so example 6, given a word name, going to write the number in standard notation. So the word name I'm working with, I've got 423 trillion. So I'm just going to write down, I'm going to find some spot over here. And this is example 6. All right, 423 trillion, so that's 423. $73 billion. Now we need 3 digits, so the first one's going to have to be a 0 to make this 73. So 073 for the billions. And now there's nothing there for the million spot. If it's missing, put in zeros. So we have no millions. So 3 zeros go there. We need those as placeholders. Next up, 647,000. 647. And then the last set, 985. 985. That brings us to your turn number 6. This is still the largest personal check ever written. Go ahead and convert that to standard notation. It's a pretty good day's work. For turn number 6, we've got 974 million, so 974. $790,000, so that's 790 here. $317. And got a little change there on the end. You know, I don't have to do that, but I'm just going to put there on the end. 77 cents. So 974, 790, 317, and 77 cents. All right, next up, we're going to be reading tables and numbers. And not just any tables, it can be tables with, if you look at example 7, they don't want to actually have to write out those big long numbers in the table. So up here in the heading it says in millions of dollars. So each one of these is actually millions. So what we have to do is take that number in the table and multiply it by 1 million to get the actual value. So example 7 asks, what were the sales of Wii Sports Resort in the European Union, in the EU? So I'm going to go down the table to Rank number 4 is Wii Sports Resort. Then head over to the EU column. And you can see the number in that cell in the table is 11.01. So it's 11.01 million. So what we're going to do is take 11.01 and multiply it by the number it says in the table, which is 1 million. Now, an easy way to multiply by a number like this is to count the number of zeros. And that's how many places you move the decimal. So we take the decimal here and move it 6 to the right. We're going to make this number bigger, so we have to move it to the right. 1, 2, and then 3, 4, 5, 6 is going to be 4 more zeros. So we get 11, 0, 1, 0, 0, 0, 0. So the actual sales are 11,010,000. The next question is, what were the sales of Super Mario Brothers outside of North America, the EU, and Japan? So that would be the other sales column, all right? Because we got North America, EU's in the second column, Japan, and then other sales. So we're looking for the other sales column. So Super Mario Brothers is rank number 2. So go over down to the second row, go over to the other sales column. You see we have 0.77. So 0.77. Now we're still going to multiply by 1 million. And that moves the decimal point over 6 places. So it's going to be 1, 2 to get here, and then 4 zeros. So we got 7, 7, and 4 zeros. And that is $770,000 in sales. That brings us to your turn, number 7. Want to find what are the sales of action games in Japan and sports games in North America. So action games are the first row. In Japan, Japan is the third column over. We get 0.04 8236. Table says we're again in millions of dollars, so we're going to take this number and multiply it by 1 million, which means we move the decimal over 6 places. 1, 2, 3, 4, 5, 6. Decimals are going to end up right there, so we get 48,236. Now, sports games in North America. Sports games are second from the bottom. Go over to the North America column, and we get 0.29 1283. Multiplying by 1 million. So we'll move it over 6 places. 1, 2, 3, 4, 5, 6. We get 291,283. So 291,283. And that wraps up this section.